So today's question that we're looking at is objects that are connected via a pulley of some sort. But in this specific situation, we're going to be looking at where the box does not move due to static friction. So what that would look like in a simulation is over here, we can see a cart and there's a mass on the right hand side over here. And the friction right now is zero. So if we're to play this, obviously the mass would be pulled down and it's going to be pulling the cart towards the right direction. Now we can add some friction and we can still see that the object moves a little bit more slowly. If you increase the friction to a certain amount, there's going to be like a maximum amount of friction that you can increase it to. And now you see that the cart does not move. So that is the situation that we're going to be looking at where we can have static friction and the cart is not going to move. Now, to start these questions, what we're going to be doing is we want to start with a free body diagram of both objects. So we have two objects over here. We can label this mass 1 and this one mass 2. We have a box and a metal mass. So we're going to do free body diagrams for both. So first, we have the block of wood. And on the other side, we have the metal mass. And for both, we're going to do our free body diagrams over here. So for the block of wood, we have gravitational force acting downwards. And we have our normal force because it is sitting on a table of some sort. So we have normal force acting upwards. So we have normal force and gravity. There is a rope. So there is going to be a tension force in this direction. And in this specific scenario, we have static friction. So there has to be static friction opposing that motion in this direction over here. So we have Fs. Now for our mass, we have a rope. So there is going to be a tension force upwards. And what's going to be acting downwards is going to be gravity. Now, when we do these questions, what we want to do is we want to define which way is going to be positive, which way is going to be negative. That just makes our life a little bit easier. A hint or a tip that I would suggest is that you want to put the direction of motion as positive. So our box is moving towards the right. So anything towards the right would be positive. So that would be positive X. And since our mass is moving downwards, is being pulling downwards, then we want to define our positive Y as down. It's just going to make our life a little bit easier when we're doing our calculations. Now, in terms of our block of wood, in terms of our Y direction, these will cancel. Our normal force and gravity, they'll balance each other out. So we are only going to be looking at our forces in our direction, because this is our box is moving only strictly in the X direction. For our metal mass, there is no motion in the X direction. There's only forces that are in our Y direction. So we're going to be looking at our forces in our Y direction. Now, once we have our free body diagram, the next step is that you want to write down the net force formulas for both of these. So for the first one, our F net, our net force is equal to our tension, which is going to the right, minus our static friction, which is going to the left. Now, we are looking for the greatest mass that can be hung. So basically what we're looking at, what's the maximum static friction that we can have before the object actually starts to move. Now, net force is equal to mass times acceleration. But we want to be specific. We're talking about, in this case, block of wood, or mass 1, and metal mass is mass 2. So we're going to say mass 1 times acceleration equals to tension force minus our static friction maximum. For our metal mass, we're going to do our F net formula. So it's going to be F net. And since we've defined our positive Y as downwards, it's going to be Fg, which is going to be positive, minus our tension force, which is in the opposite direction. So we're going to be subtracting that. Now, Net force is equal to mass times acceleration. We're going to be specific. We're going to say mass 2. That's how we've defined it. Times acceleration equals to Fg minus Ft. Now, over here, the block is without moving. So that means if it's not moving, that means acceleration has to be equal to 0. So over here, acceleration is going to equal to 0. So our acceleration is equal to 0. And in this case, our acceleration would also be equal to 0. So we are going to define that. Acceleration is equal to 0. The object is not moving. And in this case scenario, acceleration is equal to 0. The object is not moving. So in the first part, we have 0 equals to tension force minus static friction maximum. We can take this to the other side, so the negative will become a positive. So we have static friction maximum is equal to tension force. Over here in this case scenario, we have 0 equals to Fg gravitational force minus tension force. Same thing, we're going to take tension to the other side. So tension is going to equal to gravity. Now, we can start solving. Our static friction maximum, or our friction force, is going to equal to coefficient of static friction multiplied by normal force, which is equal to tension. We know that our normal force is going to balance out with our gravity. So Fn equals to Fg, which is equal to mg. So we can see that over here, our normal force and our gravity, these are just opposites of each other over here. So those are going to be balancing each other out. So we have this. So now we can plug it in. Our mu s is multiplied by mass times gravity, which is equal to tension force. And we're solving for what is the coefficient of static friction. That is what we're looking for. So mu s is equal to our tension force divided by mass and gravity. We're going to bring that to the other side. We want to be a little bit specific because we are talking about block of wood or mass 1. We want to plug this in. So mass 1 and mass 1. So we know which mass we're specifically talking about over here. Now, we don't know what the tension is, and we do know what mass 1 is. Mass 1 is equal to 4 kilograms, and we know what gravity is, which is equal to 9.8. So right now, as of right now, we don't know what tension force is, but the beautiful part is we can figure out what tension force is by going over here. So tension is equal to gravity, so we're going to plug that in. But before we plug it in, we can actually just solve for it over on this side. So tension force is equal to gravity. Gravity is equal to mg. So we're being specific. Mass of 2 times gravity. Mass of 2 is equal to 1.8 times gravity, which is 9.8. So 1.8 times 9.8, 17.64 newtons is the force of tension. So we can plug this in now. So mu s is equal to 17.64 divided by 4 times 9.8 is 39.2. So our static friction is equal to 0.45. Now, over here, there are no units. Coefficient of static friction, there is going to be no units. And the reason is because it is a ratio. And thank you.